Hi, this is Steve Ross, here to present our study on the reliability and comparison of force characteristics of the Nordic hamstring exercise. So, we can see that there's quite a strong body of evidence that indicates that the Nordic hamstring exercise is an effective training tool for increasing knee flexor strength. And a positive knock-on effect of that can be that we can see a reduction in the risk for future hamstring strain injury. Now, in addition to a training tool, the Nordic hamstring exercise has also been used more and more frequently as an assessment tool for knee flexor strength. And we can see that David Opar and his group in 2013 originally reported acceptable levels of reliability and absolute variability obtained with a sample frequency of 1000 Hertz on the original prototype of the Nord board. However, the commercially available version of the Nord board has a sample frequency of only 50 Hertz. So this raises some questions with regards to the reliability of these force time analyses. Now, if we consider jump testing, counter movement jump testing, we can see that sample frequency has been shown to have a significant impact on the reliability of those data. However, seems to have a trivial and non-significant effect on measures of peak force and rate of force development during the isometric mid-thigh pull. However, even in these scenarios, the sample frequencies as low as 50 Hertz weren't used. So it still raises some questions with regards to how much of an impact does this very low sample frequency have on our force time data analysis from the Nordic hamstring exercise. Now, additionally, we identified some issues with current Nordic hamstring exercise force analyses, in that the majority of recommendations for identifying injury risk or links to return to play criteria are made primarily only on measures of peak force or bilateral peak force asymmetries in a few different examples of widely cited studies here. However, there's been a couple of studies that have reported some additional variables, such as Mark Rowe's study reported mean force throughout the Nordic hamstring exercise, and Wade Chalker reported the use of augmented feedback on reducing force asymmetries during the Nordic hamstring exercise. However, given that the majority of studies report only peak force, we want to highlight some of the issues with that. So if we play through this example where our participant completes the Nordic hamstring exercise to initiate the movement through the extension, we see a nice steady increase in force production up until the point where we produce peak force, and when we see then a rapid reduction in force as we lower ourselves down towards the ground. So in this example, we can see that we have peak force measure of 356 newtons in the left limb and 345 newtons in the right limb. However, reporting only peak force describes just one single force data point across an entire force time series. So we're likely missing out on some quite vital information here with regards to the force time curve that precedes the onset of peak force. And we can see in this example that the force contribution from each limb may be quite significantly different throughout that range of motion. So, in addition to peak force, in this study we look to report mean force, which we've defined as the average force produced between the onset of movement and the occurrence of peak force, and also instantaneous force, which we defined as the relative force contribution from each limb throughout the range of motion. So, although I won't spend too much time in this presentation covering our methods, I will draw specific attention to how we identified our force onset threshold. So what we did there is, during the initial 1 second of data, so during which the participant's in upright kneeling, we calculated mean force plus 5 times the standard deviation of that mean force. That allowed us to create our onset threshold to represent the start of the movement. And with regards to presenting instantaneous force, we assess differences in instantaneous force by plotting normalized ensemble average curves for each limb throughout the movement with their associated 95% confidence intervals, which allowed us to identify any non-overlapping areas, which represents a statistically significant difference between limb. So this is kind of how it looked. So we can see down here is where both limbs exceed the force onset threshold. Mean force is the average force produced across that force time curve up until the point where we produce peak force. Now, with regards to reliability and variability, with peak force across all trials, we're able to report moderate levels of reliability within our threshold for acceptable levels of variability. However, with regards to mean force, although reliability was moderate, the measures of peak force exceeded the threshold for acceptable levels of absolute variability. So we expect we might be seeing a little bit of a learning curve here, a learning effect here. Now, bearing in mind that our participants were all resistance trained and familiar with the use of the Nordic hamstring exercise, what was interesting is we observed if we excluded the first trial, measures of peak force and mean force were moderate with regards to reliability and within that threshold for acceptable measures of absolute variability. With regards to instantaneous force, we observed that, let's cover that the solid lines here represent the mean, and these shaded areas represent the 95% confidence intervals for both the right and left limb. And we observed that instantaneous force was significantly higher in the right limb between 10 and 89% of normalized time. So we expect that to have some quite significant implications for strength training adaptation if we're using the Nordic as a training tool, and the right limb, the stronger limb in this instance, is experiencing greater training impulse throughout the majority of that range of motion. Would expect that right limb to experience a greater adaptation and strength training adaptation. Therefore, in this scenario, it may be desirable to include some level of unilateral training for that weaker limb. For example, the use of single leg Romanian deadlifts, where we might be able to kind of offset a little bit of that training asymmetry. What was also interesting by mapping out the instantaneous force, if you notice that there is no significant difference in peak force, which potentially could risk us masking the between limb asymmetries in this scenario. And we can see that in our individual analysis of peak force. So whether or not we included all trials or just trials 2 and 3, we noticed that there was only trivial, non-significant increases in peak force across trials, and those trivial, non-significant differences between limb with regards to peak force. Our mean force analyses also support that instantaneous force time curve, in that there was trivial to small differences in trials, one comparing mean force in trial 1 to trials 2 and 3, specifically with trial 3 being greater than trial 1. Also, in terms of our between limb analysis, mean force was higher in the right limb across all trials, and that significant effect remained even when we excluded the first trial. So our key conclusions is we recommend including greater than 3 maximal Nordic hamstring exercise trials and excluding that first trial to try and minimize the learning effect and increase the reliability of our force measures. And we also recommend including measures of peak force and instantaneous force to avoid masking any between limb asymmetries, and to allow us to better ascertain if there's any implications there for a greater training adaptation in a stronger limb if there's a greater training impulse throughout the majority of that range of motion. However, we do advise to just proceed with caution a little bit with regards to between limb asymmetries. Very similar to a lot of the work from Chris Bishop, we found in some similar data from our lab that the direction, the magnitude of the force asymmetries is not consistent throughout trials. So that may require some further investigation, which we'll look to publish in the coming months. So hopefully that's been helpful to understand how we could continue to develop our analysis of force time variables of the Nordic hamstring exercise.